Hi viewers. Welcome to this presentation on HT phase drop and link to live in distribution. Sometimes one phase of distribution feeder HT line is out due to operation do fuse, jumper opening, conductor snapping etc. In such conditions LT side voltage of distribution transformer are disturbed. Secondary voltages are not normal phase voltage. One phase has normal phase voltage whereas other two phases have half or little more or less than half phase voltages. Partial secondary voltages in two phases are in line and opposite to normal phase voltage of third phase and no phase shift of 120 degree as normal. In this condition, this LV supply is not suitable to produce rotating magnetic field necessary to run induction motor. Therefore, this arrangement is suitable to suppress motive power load in distribution system while allowing essential domestic single-phase loads for light, fan, refrigerators, etc. So this method is adopted for load shading in distribution system to control load on power system when power system is facing shortage. But for this all single-phase consumers have to be connected on phase having normal voltages during load shading. But in this case loading on three-phase is unbalanced during normal operation. Phase having all single-phase consumers connected get critically loaded during normal operation. In view of above drawback, other alternative is adopted. It is modification of the former scheme. Dropped phase is linked to other live phase as in the figure. Now LT side voltage pattern is different than earlier one. Here is analysis of LT voltages. Here is 11,000/400 volts delta star DY1 distribution transformer. There are three primary coils P1, P2 and P3 and three secondary coils S1, S2 and S3 assembled on three limbs A, B and C of transformer core. B is center limb whereas A and C are side limbs as in the figure. Primary coil P1 and secondary coil S1 are on one side limb A. Primary coil P2 and secondary coil S2 is on center limb B. Primary coil P3 and secondary coil S3 is on other side limb C. Three primary coils are interconnected in delta as usual and is connected to three-phase supply RYB. Consider Y phase is open and linked to live phase B as shown in the figure. In this condition, primary P1 and P2 is across normal line voltage, whereas primaries P3 is across the same phase. Transformer is delta star having three primary coils connected in delta. Y phase is open but linked to B phase. There is no current in primary P3 as same phase is at both ends. Primary P1 and P2 have normal line voltage. Therefore, magnetic flux is induced in corresponding core A and B only. Hence, secondary S3 on limb C having no flux linkage has no induced voltage. Whereas secondary S1 and S2 have normal phase voltage but in opposite direction as in the diagram. Rated LT line voltage is 400 V. Rated LT phase voltage is equal to 403 is equal to 230 V. Actual phase voltages. VR is equal to 230 volts. Vy is equal to 230 volts. Vb is equal to 000 volts. Actual line voltages. VRB is equal to 230 volts. VYB is equal to 230 volts. VRY is equal to 460 volts. Normal phase voltage is available onto phase R and Y. So single phase loads can be distributed on these two phases. So loading condition is better than the case when one phase is out but no link to live phase. Secondary LT voltages are in line and opposite to each other. This LT supply is not suitable to produce rotating magnetic field necessary to run induction motor. On the contrary, the motor is subject to high 460 by 400 even 15% voltage on one pair of phases. Therefore, this arrangement is suitable to avoid motive power load in distribution system for load suppression during power shortages, allowing essential domestic single-phase loads of light, fan, refrigerators, etc. In case dropped Y phase is linked to live R phase instead of B, outcome would be similar. There may be no current in primary P2 as same phase is at both ends. Primary P1 and P3 will have normal line voltage. Therefore, magnetic flux is induced in corresponding core A and C only as in the figure. Secondary S2 on limb B have no flux linkage and no induced voltage. Secondary S1 and S3 have normal phase voltage in opposite direction. However, this arrangement is favorable for mischievous users. There was low voltage into phases when only phase is out. So they need voltage booster as well phase shifter to run the motor. But in this case voltage booster is not required. Only phase shifting by capacitor is sufficient to run the motor. Solution may be to have single-phase connections equitably distributed on all the three phases as usual. Switching off and linking phase by daily rotation can have equitable treatment all consumers on different phase. So during load shading period, they get normal supply on 2 consecutive days and no supply on every third day. This make task difficult for mischievous users to run motors by different phase shifting. However, this arrangement results in balanced load during normal operation. Of course, arrangement and operation at substation for different phase drop and link is also complex and tedious. Please like, subscribe and recommend others if found worthy. Viewers' comments welcome. Thank you, viewers. Bye until meet again in next episode.